Hey everybody! Earlier today we went into the lab and we did a bunch of experiments that were examples of different reaction types. So I hope this helps you learn your different reaction types based on what's reacting and what's created. Go check them out! So through this you're going to be looking at 5 different types of reactions. Now there are more than 5 types of reactions and some of the types might overlap, but these 5 do not, and they're the most basic types. The first type you'll be looking at is called a synthesis reaction, and that's where 2 simpler substances combine to make one more complicated one. The next is called a decomposition, where one more complicated substance breaks apart into 2 or more simpler ones. Then you'll look at single replacement reactions, where an element by itself switches places with an element that is in a compound that is the similar type. So if it's a nonmetal, it will switch places with another nonmetal. If it is a metal, it will switch places with another metal. And then you'll look at double replacement, where there are 2 substances typically dissolved in water, and they each switch ion pairs. And neutralization reactions, a type of acid-base reaction, is a subset of this. You'll be looking at what is specifically a precipitation reaction. Finally, you'll be looking at a combustion reaction, which is where a substance that is based on carbon reacts with oxygen to produce carbon dioxide and water vapor. So as I said, there are other types of reactions, or some of these could be classified in different ways. For instance, redox reactions, acid-base reactions, etc. And so these are 5 general classifications. There are other reactions that don't fit into these, and some of these will overlap as you learn more about them. So for this, what you're going to be doing is using the flame from a Bunsen burner to ignite some magnesium ribbon so that it will react with the oxygen that is in the air. It is not reacting with the methane that's coming out of the faucet. It's reacting with the oxygen gas that's in the air. You need to make sure that the flame is as hot as it can get and put just the tip of the magnesium metal into the hottest part of the flame. Once it starts to ignite, you can remove it from the flame and the reaction will sustain itself. The product is magnesium oxide at the end. This reaction is going to be using heat to remove the water that is incorporated into a hydrate. In this case, it's copper 2 sulfate pentahydrate, and when it has the water molecules locked into the crystal structure, it has a blue color. As it loses the water molecules, it becomes white, and that is called anhydrate. It is only copper 2 sulfate. You can notice that the water is condensing on the walls of the test tube. We're calling this reaction 3A because we're going to do something interesting with the gas that's produced. What you're doing is you're just going to be putting in a piece of calcium carbide into water. We're going to use an indicator to show one of the products, the calcium hydroxide. It makes the water turn pink when there's phenolphthalein indicator. Phenolphthalein is not a reactant or a product in this case, and you would not include it in the balanced chemical equation. Here we are igniting the gas that is being produced, the ETHYNE gas, and notice that the flame is only staying at the top because even though the acetylene gas, the ETHYNE gas, is flammable, it does need oxygen to react. Now this procedure that you're looking at right now is not one that you are going to do in the lab. We're trying to show the importance that the phase of the substances has on whether or not they will react. This is a reaction between these two chemicals, that's true, but it's important that the phase is correct, that they are dissolved in water when they react. And you can see that just putting the two powders together does not do anything. This is the correct way to do this procedure. So these two bottles, that one has lead 2 nitrate and it's dissolved in water. It has a concentration of 0.1 m. This is potassium iodide. It also is dissolved in water with the same concentration of 0.1 m. All you have to do is put them into 2 separate test tubes and then mix them. And you get this bright yellow product. The yellow product, it looks like it's all throughout, but if you let it sit over time, it does settle out and could be completely filtered out, and you would have just a clear liquid. The clear liquid wouldn't be only water, it would also have the other product, the potassium nitrate. Next, you're going to make a big old mess by putting some ammonium dichromate into a heat source. What it does is it turns the ammonium dichromate into chromium 3 oxide, which is a green powder, turns it into nitrogen gas and water vapor, which push the green powder out of the test tube. It's important to try to spread it out as much as possible and to keep your test tube tilted. That way you can heat it completely. This reaction is going to be between zinc and hydrochloric acid. The source of the zinc is going to be from a penny. Pennies, up until 1982, were pure copper, but after 1982, they are mostly zinc with only a thin coating of copper. So what you're going to first do is use a triangular file to make some notches to expose the zinc, and you'll see that it's a different color. And then you're going to put that into the hydrochloric acid. The bubbles that are being produced are hydrogen gas, though we're not producing enough of it to ignite it, to test it. And then the other product, the zinc chloride, is staying dissolved in the water. This is a reaction between silver nitrate, which is dissolved in water, and a piece of copper, which is going to be a copper wire. You need to be careful with the silver nitrate. It stains clothing and skin. It'll stain skin for about a month, and in that month, the skin smells like dirty pennies. So you're going to put in just a small amount, and then a small amount of copper wire. This reaction is using heat and a catalyst to turn potassium chlorate into potassium chloride and oxygen gas. The manganese 4 oxide is a catalyst and so would appear over the arrow in the balanced chemical equation. And the product of oxygen gas is going to be confirmed by putting in a burning wooden splint. The wood is not a reactant or product in this, it's just to confirm that the bubbles that are being given off are oxygen gas, because things burn much better, much more quickly in oxygen gas. Okay.
Ready?
Yep.